Good day everyone, here's our math challenge for today. And here's our question. Solve for the value of n given that the summation of x as x goes from n up to 3n must be equal to 110. Now, if you want to try this problem, you can pause this video. You have 20 seconds and timer starts now. Time's up. Now, let's answer this question together. The question is, what is n such that the summation of x as x goes from n up to 3n must be equal to 110? Now, let's visualize this question. First thing first, let's have a straight line, and then let's locate the 0. Now, let's have some distance, then we call this as n. Now, if we triple this distance, we have 3n. So this distance must be 3 times n. So we have n, 2n, and we have 3n. Now we will use some identity to answer this question. So we know that the summation of x as x goes from 1 up to k must be equal to k times k plus 1 divided by 2. In this diagram, we can find the sum from 1 up to the integer that is less than n. That integer is just n minus 1. So, we can find the sum of x as x goes from 1 up to n minus 1. So, what we're going to do is to replace all k with n minus 1. So, we have n minus 1 times n minus 1 plus 1 divided by 2. Now, let's simplify. Minus 1 and plus 1 is just n. And n minus 1 times n over 2 can be written as n times n minus 1 divided by 2. So this is the sum of all numbers from 1 up to the integer that is less than n. Also, we can get the sum from 1 up to 3n. So what we're going to do is to replace all k with 3n. So the sum from 1 up to 3n is just 3n times 3n plus 1 divided by 2. Now take note that we know the sum of x as x goes from n up to 3n must be 110. Therefore, if we get the sum from n up to 3n, we get 110. Now we have an equation that it says that if we add n times n minus 1 divided by 2 plus 110, we get 3n times 3n plus 1 divided by 2. Now we can solve for the value of n. First thing to do is to simplify first the terms on the left hand side. 3n multiplied by 3n plus 1 will give us 9n squared plus 3n. Now distribute this n, this will give us n squared minus n. Now to cancel out this denominator, let's multiply all terms by 2. Now let's combine like terms. Let's subtract n squared on both sides. And then add n on both sides. Then let's equate this equation to 0. Now notice that 8, 4, and 220 are divisible by 4, so divide all terms by 4. So we have now 2n squared plus n minus 55 equals 0. This trinomial is factorable. In fact, if we factor this trinomial, we get 2n plus 11 multiplied by n minus 5. Now take note that if we multiply these two factors, we get the original expression 2n squared plus n minus 55. Now let's go back to its factored form. Now since it is equal to 0, it follows that at least one of them must be equal to 0. So we can say that 2n plus 11 equals to 0, or n minus 5 must be 0. Now using the first equation, we can find the value of n. Now if we do that, we get that the value of n must be negative 11 over 2. Now using the second equation, we get that the value of n must be 5. Now take note that this n must be an integer. Therefore, we have the answer of n equals 5. This is easy to verify because if we add the numbers from 5, 6, 7 up to 15, we get exactly 110. Therefore, sure enough that n must be 5. And as always, we are done.